Well, hello, ladies and gentlemen. It is a great honor for me being here and standing in front of you today. I'm very, very excited, but don't worry about me. I will be fine. My name is עומר Parives. I'm 17 years old, and I participated in the project Young Female Engineers of Tomorrow. I'm the representative of one of the groups whose project is Pegasus Initiative, and I want to tell you a little bit about my group's project and about the project from my point of view. But before I start my formal lecture, I have a little confession for you. Well, all of my closest friends are boys. You see, it's because I practice technology. And it seems as if the field of technology is dominated by boys. Look, I'm a person of science. My extended subjects in school are physics, electronics, and computer science. I also learn computational science in Weizmann Institute. I learn in Israel's National Cyber Program. Some of the projects I've built are a hovercraft that is controlled by a smartphone. I created a simulation of cell division and the creation of cancerous tumor. I built a firewall and an antivirus. And I program in C, C Sharp, C, C Sharp, C++, Python, Java, Assembly, and MATLAB. And actually, science consumes a big part of my day. So the amazing fact is that in all of these programs, there are hardly any girls. I want to show you some of the statistics of girls in my classes. Well, electronics, 8%, physics, 6%, cyber, 16%, computational science, 16% as well. And the average is 11% of girls in my classes. I hope that the women percentage here in the court is much bigger. Is it? Don't worry, I wouldn't ask you to raise your hands. But I want you to understand what an opportunity it was for me to participate in a project such as this one. Because the women percentage in this project is 100. For me, it was the first time that I was surrounded by so many girls who are so similar to me. And for the women among us, you probably know how difficult it is to be surrounded by so many of us. But for me, it was the first time, and it was incredible. In addition, we were empowered by meeting such inspiring women and female engineers in a place like Israel Aerospace Industries, which is the peak of technology and science in Israel. And beside all of this, scientifically, it was very challenging and enriching project where we got a glimpse of the engineering industry and the working process on real complicated engineering projects. So I mentioned before some of my interests. Here I really had the opportunity to express them, and it was amazing. Well, I'm the representative of one of the groups in the project, and our mission was to plan a futuristic personal aircraft for everyday transportation. When we got the assignment, it didn't seem to us fictional. It was mainly big and complicated, so of course we took it. Well, the need was obvious. How many of you feel that traffic jams drive you crazy? In addition, car accidents claim the lives of many people worldwide. Emergency vehicles should arrive to emergencies as urgent as possible. So again, the need was obvious, and we took it very seriously. Planning a vehicle, an aircraft, or both in this case, is, as I mentioned before, not an easy task. For all of us, I suppose, it was the first time that we dealt with such a large engineering project. So we browsed the web for hours. We investigated many aircrafts and the principles. We viewed some similar initiatives. We started with answering the basic questions. For example, number of passengers, traveling range, size and structure. I don't think it works anymore. And after that, we had to deal with much more difficult problems, for example, infrastructures. Because think about it. Are we going to set traffic signs in the sky? I don't know. Safety. car accidents are dangerous, but air accidents are much worse. Licenses. Will we demand drivers to hold a pilot license? It's not realistic. Last but not least, materials and energy, including economic and ecological considerations, which is very important. So we are proud to present to you our project, Pegasus Initiative. Well, the main properties of the aircraft. It is for 1 to 2 passengers. It is designed for travels within the country up to 500 kilometers. Its size is about the size of a normal car, and it has an aerodynamic structure. I will explain later. And here we can see a sketch of the aircraft. So I hope it will work, but my very good friend Ori Levy and I created a 3D simulation that shows the concepts of the aircraft and the flight experience. So I will let the pictures to speak for themselves while I'm talking, but I want you to follow me because it is very important. So Pegasus is the future of personal aircrafts for everyday transportation. By using the Coanda effect to the full, it takes off not vertically, but like birds, diagonally. And it does not require a runway. Actually, by ejecting gas at great speed on the upper surface of the wing, it creates the conditions of it to take off. Pegasus also uses solar energy, and it is thrusted by plasma engines. What is plasma engines? Well, today, electrical energy is mainly used to power propellers. Plasma engines enable us to convert electrical energy directly into thrust, which is very efficient. So Pegasus also has a car mode, which means drivers can land their aircrafts and park them as normal cars, which is very comfortable and nice. One of the most important points of the aircraft, and we thought about it a lot because it is very important, is the point of auto-routing, which means our aircraft will be routed by automated systems. So why auto-routing? We thought about it, and we came to the conclusion that we are terrible drivers. Humans inherently has a half-second lag in almost any quick response they need to have. Even a half-second delay can mean the difference between life and death, right? And automated machines don't have it. They have microseconds. So actually, the transportation network of the future will be safer when we turn it over to computers. In addition, it will solve the problems I mentioned before of air accidents and licenses, and it will allow us to have full control on the transportation in the sky, including commercial airplanes and birds. So, flying concept, I mentioned it before, but our aircraft has an aerodynamic structure. In that way, it can exploit Coanda effect to the maximum. It also has 4 rotors, and it uses solar energy, and it is thrusted by plasma engines, which, as I said before, convert the electrical energy into thrust. I want to thank my wonderful team and my 2 amazing and inspiring mentors, Michelle Chassid and Ronit Netanzon. Thank you very much. Before I finish, I want to add some personal words. I always end my lectures with quotes from Alice in Wonderland. So I chose for this lecture the quote, "Sometimes I've believed as many as 6 impossible things before breakfast." It was Alice who said that, and she was a girl. But seriously, this project really taught me to believe as many as 6 impossible things before breakfast. And I really hope that many projects will keep promoting girls to take significant parts in science, technology, and engineering. So thank you very much, and don't stop believing.
Thank you to Omer, Gaia, and Doreen for these amazing presentations. We have time for a couple more speakers before we continue. I'm proud to welcome our next speaker, Ms. Inbal Sternberg, Head of Sustainability Division at IAI, Chemical and Biomedical